Extension of transformations. The characteristics of transformations, stretch, compression, reflection, and shifts apply to all functions, including piecewise functions. Make a table of points to help you transform the following piecewise function. Call it f of x. So we can see with the function that we have right here, we have a value right here. That's easy to see. A value right here, a value right here, and a value right here. This value is negative 5, 1, 2, 3, 4, 5, 6, negative 5, negative 6. We have a value negative 2, 4. We have a value 0, negative 2. We have a value 5, 1. Our domain is going to be negative 5 to 5. Our range is from negative 6 to 4. Our increasing intervals, we have one from negative 5 until negative 2, and then we have another one from 0 to 5. Our decreasing intervals are from negative 2 to 0. We have two local minimums, but since it doesn't specify whether it's an absolute or a local minimum, we're going to assume absolute. So this would be our absolute minimum, which is negative 5, negative 6. Same with maximums. If we thought it was a local, we would have 2. However, since it doesn't specify, we're going to assume absolute maximum, which is negative 2, 4. Our zeros, where it crosses the x-axis, we have 1, 2, 3 of them. We'll say the first one is about negative 3.20. The next one is about, we'll say, negative 0.70. And the last one we'll say is about 2.90. A turning point is when we go from increasing to decreasing or decreasing to increasing. So you can see that we have two turning points right here. These turning points are negative 2, 4, and 0, negative 2. Now, we're going to want to keep these ordered pairs in mind while we complete the rest of our transformations because they're going to be important to us. So for this transformation here, I kept all my ordered pairs on the side so that I'm able to look at it. We can see up here we have a 1/2 times f of x. We know f of x is essentially just y, so what I'm going to do is I'm going to multiply 1/2 by all of my y's. The x's stay the same, so we keep all the x's the same. We write them down, negative 5, negative 2, 0, and 5. And now I'm multiplying all the y's by 1/2, which gives me negative 3, 2, negative 1, and 1/2. All I have left to do now is graph my points. Negative 3, negative 2, 2, 0, negative 1, 5, 1/2. And I connect my dots. Our domain stays the same. But our range has changed a little bit. It's been split in half. So our range is now from negative 3 to 2. And that's how we transformed this function. Now let's look at the next one. This one is the same thing, but now we're multiplying all of our y's by negative 2. Keep the x's the same. Multiply the y's by negative 2, which gives us 12, negative 8, 4, negative 2. Some of these numbers are going to be way too big to graph on this graph, but we will try our best. 1, 2, 3, 4, 5. 12 is going to be way up here. Negative 2, 1, 2, 3, 4, 5, 6, 7, 8. 0, 4, 2, 3, 4, 5. And we connect our dots. Trying to make our lines as straight as possible. Our domain stays the same from negative 5 to 5, and our range now has doubled in size. It is now going to be from negative 8 to positive 12. Now let's look at the next problem. We have this function here, f of x minus 1. So this minus 1 is associated with our x. When we know something is associated with the x, we know that it's going to do the opposite of what we normally would think it would do. So this is telling us that we need to move our function 1 to the right, which means we need to add 1 unit to all of our x's, which brings us to negative 4, negative 1, and 6. And our y's stay the same. So now our new points to graph are negative 4, negative 6, negative 1, 4, 1, negative 2, and 6, 1. And this is our new function. Now, we know our domain is going to all be shifted 1 to the right, so our domain is now our range is still negative 6 to 4. Now let's move on to the next problem. We have now f of x plus 2. So essentially y plus 2, which means we're adding 2 to all of our y's. The x's stay the same. We're adding 2 to all of our y's. And now we plot our new points. Our domain is going to stay the same. Our range now gets shifted up 2. So our range is now from negative 4 to 6. Now let's move on to the next one. This one has 2 transformations. This is telling us we are going to move our function 1 to the right and 2 up, which means we're adding 1 to all of our x's and we're adding 2 to all of our y's. So when we do that, we get negative 4, negative 1, 1, 6. When we added 1 to all of our x's and we add 2 to all of our y's, we get negative 4, 6, 0, 3. And now we graph our new points. Our domain is from negative 4 to 6, and our range is also from negative 4 to 6. And now we are done.